This is SpaceTime, Series 26, Episode 33. Coming up on SpaceTime, a board of inquiry hands down its formal findings into the Vega C rocket failure, the most detailed study yet of a weather phenomenon called a gigantic jet, and how do you tell what the time is when you're on the moon? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A European Space Agency Board of Inquiry has found a fault in a nozzle in one of the rocket engines caused the failure of the European Space Agency's Vega C rocket during its second flight in December last year. The independent investigation found gradual deterioration of the rocket nozzle and, more specifically, unexpected over-erosion of a carbon-carbon insert inside the nozzle led to the loss of the VV-22 mission in the skies above the Kourou spaceport in French Guiana on December the 20th. The first stage of the 35-metre-tall four-stage Vega C rocket, called the P120C, worked just fine for liftoff and for initial climb. But it was following main engine cutoff, first stage separation, and second stage ignition that the second stage Zefiro 40 suffered the failure. The flight was carrying two satellites for Airbus's Pleiades Neo-Earth imaging constellation. The Board of Inquiry found the criteria used to accept the carbon-carbon throat insert was not sufficient to demonstrate flight worthiness. The Commission has therefore concluded that the specific carbon-carbon material can no longer be used for flight. The CC insert on the Zefiro 40 was procured from a Ukrainian company called Avio, and the Commission says its investigators found a flaw in the homogeneity of the material. Avio will put in an immediate alternative solution using another carbon-carbon material which Ariane Group makes, and which is also used on the original Vega C Zefiro 23 and Zefiro 9 nozzles. Arianespace says it would implement the recommendations before targeting another launch of the Vega C, possibly later this year. The Vega C is a newer, more powerful successor to the original Vega launch vehicle, which first took flight in 2012. The Vega C can send 2,300 kilograms into a 700-kilometre high sun-synchronous orbit. That compares to the original Vega, whose launch capacity was 1,500 kilograms of payload. This is SpaceTime. Still to come, the most detailed study yet of a weather phenomenon called a gigantic jet, and working out the time on the moon. All that and more still to come on SpaceTime. A detailed three-dimensional study of a massive electrical discharge that rose 100 kilometres into space above an Oklahoma thunderstorm has provided scientists with new insights into an elusive atmospheric phenomenon known as a gigantic jet. Scientists say the Oklahoma discharge was the most powerful gigantic jet ever studied, carrying at least 100 times as much electrical charge as a typical thunderstorm lightning bolt. The gigantic jet moved an estimated 300 cumulobs of electrical charge into the ionosphere, the lower edge of space, from the thunderstorm. Now, typically, lightning bolts carry less than 5 cumulons between clouds and the ground or within clouds themselves. The upward discharge included relatively cool 200 degrees Celsius streamers of plasma, as well as structures called leaders that are very hot, more than 4,500 degrees Celsius. The study's lead author, Levi Boggs from Georgia Tech, says he was able to map the gigantic jet in 3 dimensions, achieving high-quality data. The observations, reported in the journal Science Advances, show very high-frequency sources above the cloud tops, which had not been seen before with this level of detail. Using satellite and radar data, the authors were able to learn where the very hot leader portion of the discharge was located above the cloud. The VHF and optical signals definitely confirmed what researchers had suspected, but not yet proven. Namely, that the VHF radio signals from lightning is emitted by small structures called streamers that are at the very tip of the developing lightning, while the strongest electrical current flows significantly behind this tip in an electrically conducting channel called a leader. The fact that the lightning jet was detected by several systems, including a lightning mapping array and 2 geostationary satellite optical lightning instruments, was a unique event and gives scientists a lot more information on gigantic jets. Gigantic jets have been observed and studied over the past 2 decades, but because there's no specific observation system to look for them, detections have been rare. Boggs learned about the Oklahoma event from a colleague who told him about a gigantic jet had been photographed by a citizen scientist who had a low-light camera in operation on May the 14th, 2018. Fortuitously, this event took place at a location with a nearby VHF lightning mapping system within range of 2 next-generation weather radar locations and accessible to instruments on satellites from NOAA's Geostationary Operational Environmental Satellite Network. The detailed data shows that these cold streamers start their propagation right above the cloud top. They then propagate all the way up to the lower ionosphere, up to an altitude of 100 kilometres, making a direct electrical connection between the cloud tops and the lower ionosphere at the edge of space. That connection then transfers thousands of amps of current in about a second. The upward discharge transferred negative charge from the clouds to the ionosphere, typical of gigantic jets. The data showed that as the discharge ascended from the cloud tops, VHF radio sources were detected at altitudes of 22 to 45 kilometres, while optical emissions from the lightning leaders remained near the cloud tops at altitudes of around 15 to 20 kilometres. The simultaneous three-dimensional radio and optical data indicate that VHF lightning networks detect emissions from streamer corona rather than the leader channel. And that has broad implications for lightning physics beyond just the gigantic jets. Researchers speculate gigantic jets may be shooting charge into space because something's blocking the flow of charge downwards or towards other clouds. Records of the Oklahoma event show little lightning activity from the storm before it fired the record gigantic jet. Boggs says for whatever reason, there's usually suppression of cloud-to-ground discharges. There's a build-up of negative charge, and then the conditions in the storm top weaken the uppermost charge layer, which is usually positive. In the absence of the lightning discharges we normally see, the gigantic jet may relieve the build-up of excess negative charge in the cloud. For now, there's still lots of unanswered questions about gigantic jets, which are just one class of a mysterious group of transient luminous events. That's because observations of these phenomena are all rare and happen by chance, usually by pilots or airline passengers who just happen to be seeing them, or from ground observers operating night scanning equipment. Estimates for the global frequency of gigantic jets range from 1,000 to maybe 50,000 a year. They're reported more often from tropical regions of the globe. However, the Oklahoma gigantic jet, which was twice as powerful as the next strongest one, wasn't part of a tropical storm system. Beyond their novelty, gigantic jets could have an impact on the operation of satellites in low Earth orbit. As more spacecraft are launched, signal degradation and performance issues could become more significant. And gigantic jets can also affect other technologies, such as over-the-horizon radars that bounce radio waves off the ionosphere. And of course, they're really cool to look at. This is SpaceTime. Still to come, an international conference in the Netherlands starts the process of working out how to tell time on the moon. And later in the science report, a new study has found that the recent flooding of the Murray-Darling system, Australia's largest river network, has created ideal breeding conditions for many native species. All that and more still to come on SpaceTime. A new era of space exploration is on the rise, with dozens of moon missions planned for the coming decade. Not only will humans return to the lunar surface, this time to stay, but a flotilla of spacecraft and an orbiting lunar space station are also being planned. All that means there'll be dozens of missions operating both on and around the moon, and all of them will need to communicate not just with mission managers, but also with each other in order to fix their positions independently from Earth. And so the European Space Agency has started considering how to keep time on the moon. A meeting in the Netherlands has now established a plan for a common lunar net architecture. It'll cover lunar communications and navigation services with mutually agreed to standards, protocols and interface requirements, allowing future lunar missions to work together, conceptually similar to what we did on Earth for the joint use of the GPS and Galileo navigation systems. and timing will be a crucial element, so defining a common internationally accepted lunar reference time will be vital. But how do you do that? I mean, the South Pole on Earth, the Edmondson Station, uses New Zealand Standard Time only because it's the nearest supply base. But that doesn't mean all other countries on Antarctica are using it. And if there's no real agreement on how to tell the time at 90 degrees south on Earth, how are we going to tell time on the Moon? Up until now, each new Moon mission has operated on its own timescale, exported from Earth, with deep space antennas used to keep onboard chronometers synchronized with terrestrial time. However, this way of working won't be sustainable in the future lunar environment. Once complete, the Lunar Gateway space station and a base near the lunar South Pole will be open to astronauts, resupplied by regular Artemis launches. Meanwhile, there'll be numerous unmanned spacecraft also in orbit and on the ground, and each will be on its own mission, often interacting with others, sometimes performing joint observations or carrying out rendezvous operations. ESA is already developing its Moonlight program for lunar communications and navigation, while NASA will provide its own lunar communications relay and navigation system. But to maximize interoperability between these two systems, they'll need to employ the same timescale, along with the many manned and unmanned missions they support. Interoperability of time and geodesic reference frames has been successfully achieved on Earth for global navigation satellite systems like Galileo and GPS, which reference UTC or Greenwich Mean Time. It's this system which allows your smartphone to compute your exact position down to a metre or better. But stable timekeeping on the Moon will throw up its own unique challenges, such as taking into account the fact that time passes at a different rate on the Moon due to the Moon's specific gravity and velocity effects. Clocks on the Moon will run faster than their terrestrial equivalents, gaining around 56 microseconds or millionths of a second per day. And their exact rate depends on their position on the Moon, ticking differently on the lunar surface compared to orbit. Accurate navigation demands rigorous timekeeping because sat-nav receivers determine their location in space by converting the times that multiple satellite signals take to reach it in order to measure distance, and then multiplying that time by the speed of light. Space agencies will need to determine whether a single organization should be responsible for setting and maintaining lunar time, and whether lunar time should be set on an independent basis on the Moon or kept synchronized with the Earth. And of course, that's all still got to work on human timescales for those on the Moon. Remember, a day on Earth lasts 24 hours, but a lunar day lasts 29.5 Earth days. That includes a freezing fortnight-long lunar night, with the whole Earth nothing more than a small blue dot in a distant dark sky. This report from ESA TV.
Going to the Moon was the first step. Staying there is our next ambition, with dozens of international public and private missions setting their sights on the lunar surface in the coming years. But the technologies we take for granted here on Earth, satellite navigation systems like Galileo or GPS, video calls, or even fast file transfer, are very limited on the Moon. Since the Apollo program, very few lunar missions have managed to land successfully. We cannot have a sustainable lunar presence without reliable and autonomous communications and navigation. That's why ESA is working with its industrial partners on the Moonlight initiative to become the first off-planet commercial telecoms and satellite navigation provider. Launched into space, 3 or 4 satellites are carried into the Moon's orbit by a space tug and deployed one by one to form a constellation of lunar satellites. These relays connect to Earth via 3 dedicated ground stations, forging a data network that spans up to 400,000 kilometres. The constellation's orbits are optimised to give coverage to the lunar South Pole, whose sustained sunlight and polar ice make it the focus of upcoming missions. Moonlight will provide data capacities sufficient to serve these planned and future missions over the coming decades, with a navigation service that enables accurate, real-time positioning for all lunar missions. The Argonaut, this or any lunar lander, could greatly benefit from the Moonlight program. With a simplified navigational subsystem, our lander saves mass, reducing cost and enabling other equipment to be carried. Its position is tracked in orbit and descent with accuracy of just a few meters, sending real-time telemetry and video footage to Earth as it touches down safely in its target area. It completes health checks and deploys its payload, whether that's supplies for the moon base or a science mission. A rover connects to the Moonlight network, either via the lander or directly to the constellation. Navigating autonomously, it saves huge operational costs, collecting lunar samples that can be brought safely back home again. The Moonlight system is designed to be scalable and adaptable. ESA is working closely with NASA on LunarNet, a new framework for lunar communication and navigation standards that ensures compatibility.
This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that a history of child abuse could be linked with altered brain function in adults. The findings, reported in the Journal of the American Medical Association, are based on data from 768 kids in Sydney. The authors found that people who experienced abuse during childhood, but not adolescence, experienced altered functioning in their brains for systems associated with perceptual processing and attention. These brain changes may be due to a heightened awareness of their environment due to being exposed to high levels of threat at an early age. The authors also found that more women than men experienced childhood abuse in the study groups, and that more pronounced brain changes were found in men who had experienced abuse, possibly due to the different rates of brain development in the sexes. Well, just like our computers at home, quantum computers are prone to errors, which will need to be corrected in order to allow them to fulfill their tasks properly. Now, a report in the journal Nature claims a team of researchers from Google Quantum AI say they've developed a system that could be scaled up for correcting errors without triggering a bunch of new errors, a problem many correction systems have struggled with. So they tested their system on different sizes of quantum processors, and they found that larger versions of the system actually perform better than their smaller counterparts. The researchers say more work still needs to be done to reduce the number of errors that slip through their net, but at least it's a step in the right direction. A new study has found that flooding in the Murray-Darling River system, Australia's largest, is creating ideal breeding conditions for many native species that have evolved to take advantage of temporary flood conditions. A report in the journal Ecosphere shows how scientists have now developed a virtual model of the Murray River in order to reveal a crucial link between natural flooding and the extinction risk of endangered southern bellfrogs, also known as the growling grass frog. Southern bellfrogs are one of Australia's 100 priority threatened species. This endangered frog usually breeds during spring and summer, when water levels are supposed to increase in their wetlands. However, the natural flooding patterns in Australia's largest river system have been negatively impacted by expansive river regulation that in some years sees up to 60% of river water extracted for human use. Scientists with Flinders University have now built computer simulations of the Murray-Darling Basin wetlands filled with simulated southern bellfrogs. And by changing the simulation from natural to regulated conditions, they found that modern conditions in real life are dramatically increasing the extinction risk of these frogs. The immortal Dr. Sheldon Cooper.
I don't mean to be rude or discourteous, but before we begin, I'd just like to say that there's absolutely no scientific evidence to support clairvoyance of any kind. Which means, and again, no insult intended, but you're a fraud. Your profession is a swindle, and your livelihood is dependent on the gullibility of stupid people. But again, no offense.
With that sort of spark logic, the proverbial question, why do people go to psychics, must be asked. Still, the idea of consulting a psychic remains a popular pastime, even though they're almost always wrong in their predictions, and the stuff they claim to know about you is usually provided either through cold reading or by checking out your social media history first. Tim Mendham from Australian Skeptics says even the royals love going to psychics, but He can't explain why either.
It is the perennial question that we always ask, because especially with psychics, there is absolutely no scientific evidence that psychics can do what they say they can do. There's a lot of evidence that shows that they can't do what they say they can do. And we had a big study where we looked at thousands of psychic predictions from hundreds of psychics to find out how accurate they were. They were making predictions of things happening in the future. And they did appallingly. They did about 10-11% of their predictions were actually accurate. And you would think that if they were doing this professionally, which a lot of them do, they would have a lot higher percentage than that, but they don't. So their predictions are poor and their psychic practices are unsubstantiated. Nonetheless, a lot of people go see psychics. You'd have to say a percentage of those might be doing it for fun, just a weird experience. They go see a scary movie, they go see a psychic. You probably get more out of a scary movie. You probably get a longer time, certainly, out of it for your money. But a lot of people go see a psychic, and then some people get to take it very seriously and almost become addicted to psychic readings, whether it's from one particular psychic or whether it's a whole bunch of them.
Well, it depends how good they are at cold reading, isn't it?
Cold reading, hot reading is very common, especially these days with a lot of the social media. People basically give away all the information that a psychic might then feed back to them. But the issue is that's often said, and I've heard it so many times, but are they doing any harm? Might it just be comforting, especially for people trying to contact dead relatives? They are scared of sort of the finality of death and therefore would like it to be continued, and especially to talk to people they love. And therefore, is the psychic someone who can hold their hand and say, don't worry, it's all okay, Mummy's still up there and she still cares about you, etc. The danger is that what you are doing is feeding someone that I would say is rubbish. It's false. It's giving false hope to someone. There are psychics who do it as a con, and there are psychics who do it because they believe it, right? The percentage is the interesting one for discussion amongst skeptics as to what percentage are cons and what people are harmless ladies wearing sort of gypsy outfits who are sort of reading tarot cards and who really believe it.
All know they're conning people.
Yeah, well, you can say that. I don't know how legally you can say that. We have had messages from psychics who say they're all cons, except for me, of course, you know. But actually some of them say we're all cons, including the one telling us this top secret information. I would say, to me personally, a high percentage, so especially the high-profile ones, I would think. But people go to them, people get some sort of comfort out of them, and the people who put forward that theory that what's the harm, they're comforting people. You could say that about a lot of things that are sort of dangerous but initially comforting. You could say it about drug dealers. You could say it about con men. You could say it about a range of different professions that are offering you comfort but are really making you believe in falsehoods and taking your money. And so,
sound like a
as
politician.
this conversation, yeah, well, like a politician, yeah, well, they're very similar. This conversation article, I think, is naive, quite personally. And I've seen other things that have come out. There's a recent major book that came out which had much the same thing. Interestingly, saying they're all cons, but they're useful. And I think, where's the sense of ethics in this, actually? Telling someone a lie doesn't justify being nice to someone, unless it's Santa Claus. It is a very strange attitude that the people who are almost apologists, psychics, are saying, yes, but they do good. And that's why people keep coming back to them. Yes,
that's because they keep thinking about rainbows and unicorns.
The adult thing is actually is the interesting point as to how sort of discerning adults are. Adults have a greater sense of grief, a longer-lasting sense of grief than 4-year-olds do. And they have the money to spend, of course. But to me, it's an age-old problem of, yes, they probably do help someone to make them feel better, etc. But is that justify a shonky profession? Whether it's consciously shonky or whether it's sort of unconsciously done by people who believe they're doing good. It's like a clergyman who might be an agnostic or an atheist even, and though they do exist, still believe they are doing good for people when they comfort them. And you think, I don't know. I tend to feel that ethics should be in the mix somewhere, but it often isn't in these things. And when you're talking about crossing people's hands with silver and paying for these services, they should at least be more accurate, more real than they are. And certainly from our studies, there's not a lot of them who are very accurate.
That's Tim Endham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.